Hello everyone, my name is Alexander Herr. I am the project manager of this group, and our project is about drone localization using machine learning. In this project, I will be working alongside Gilbert Barr, and we are being advised by Dr. Razouk. And so the objective of our project is to implement object localization using machine learning. And so object localization is a sub-branch of object detection. And so what we're essentially doing is locating an object in a 2D domain and finding out where it is in the 3D physical domain. To be able to perform this, I will go over the list of components that we will need to be able to do this project. So the components that we used was the NVIDIA Jetson Nano, which is going to be running one of the neural networks that we developed. And in this project, we developed two neural networks that perform their own specific tasks, and I'll go over it more in detail later. And then we used the OAK-D camera, which was used to perform our object detection inference, and it was crucial for detecting the drone. We also used this camera for image collection. And then we have the crazyflie drone, which is going to be the drone that we're going to be detecting, and the crazyflie bolt, which is an expansion deck that allows for brushless motor use and larger battery. It also utilizes the crazyflie framework, which is going to be needed to maneuver the drone autonomously. And lastly, we have the Steam VR base station. So this is going to be needed for detecting the drone in the physical space. Since this application is engineered to detect people in enclosed space, we figured that it would be perfect for detecting our drone. And so this is a project overview that we drew to be able to showcase how the drone is going to be working with every component. And so the object that's going to be detected is going to be the crazyflie 2.0 drone. And this drone is a drone that's capable of being configured for autonomous flight. So what we want to first do is to first perform object detection, which is done by first collecting images of the drone and then implementing transfer learning. So transfer learning is a learning method that we use, and it's used in machine learning that allows you to take a pre-trained model and retrain it to your custom needs. In our case, we used a model called YOLO V4 Tiny to train our model, and we used around 600 images. So once we're able to train that, and once we detect the drone in the 2D domain, we can retrieve the coordinates of the drone in that 2D domain by first getting the bounding boxes. So once we get the bounding boxes, we can calculate the center of the square, and then basically every time that we get a bounding box, we calculate the center of that square and we get the X and Y coordinates from there. Now that we have those X and Y coordinates, we can then feed it to a second neural network, which is going to take those X and Y coordinates and translate that into coordinates that the lighthouse system could take. Because the lighthouse system takes in physical coordinates, and those coordinates are going to be different from our camera coordinates. And so we built a regression model that does that conversion. And how the project is going to work in the end is that those two neural networks are going to be interfacing with each other to give us live feedback. Now Gilbert is going to be going over the project demo, and he's going to be showing us doing data collection, and he will be showing the end model and showing us how the project works overall with live data.
Hello, Gilbert here. So I'm just going to go over a little setup we have. We have our camera and a lighthouse system set up here. And we also have another lighthouse over here, which is what we're using to track the position of our drone. And this is what we're using to do our tracking. So right here we have the drone set up at the origin of basically our global reference. So everything is basically in orientation to this drone. Our x-axis is facing positive in the front of the drone. Our y-axis is positive to the left of the drone, and our z-axis is positive above the drone, basically. So this is our little setup that we have in USRT, and yeah. So this is our data collection script that we're using. Let's go.